In this lesson, we're going to take our first look at multiprocessing in the flesh, now that we have at least working definitions for multiprocessing and multi-threading. I'm in my command line prompt on my Mac, and you can see the command cat file.txt. If you're on a Windows machine, you can use type, T-Y-P-E, instead of cat. So let me show you the contents of this file. It's a simple text file, and you can see it lists 7492 and so on. These strings are not in sorted order, so what I'm going to do now is rerun this command, and I'm going to put in a vertical bar, the so-called pipe operator, and then on the right-hand side, I'm going to put sort, and you're going to get the expected output. So on the left-hand side, cat file.txt prints out the contents line by line of that file, and the contents are then piped, that's the term used, into the sort program, and the sort puts them in lexicographical order, so basically alphabetic order. The thing that's of interest to us is that we have multiprocessing in action. There are two processes at work. On the left-hand side, there's the cat process, and on the right-hand side, there's the sort process. By the way, the sort uses blocking I/O, and so it doesn't do anything until it gets the contents of the file. It then sorts the contents of the file and prints them out to the screen. So the simple pipe at the command line is a nice example of multiprocessing at work. So let's take a closer look at the details, at what's going on here. This is one of the working files. It's called multiprocessing.txt. And what I do at the top, basically, is to repeat what I just did. So there you see the cat command. And I summarize here. The important thing is this. If we're on a machine with multiple processors, and in this case we are, what you're going to have is true multiprocessing. Here I summarize a bit how the pipe operator works. And down here is a conceptual overview of the pipe operator. So a depiction. On the left-hand side, you see a writer, so that's the right end of the pipe. The vertical bar, again, on all modern operating systems, is the pipe operator, and then on the right-hand side is the reader. By the way, in a forthcoming code example, we're going to do a pipe. This is called, by the way, an unnamed pipe. We're going to do a pipe in code. So here I summarize what's at play with the processes. So basically we have two programs in execution, in this case cat on Unix type systems, or type on a Windows system, followed by sort. Now let me generalize this a bit. When you do multiprocessing, there are two general approaches, one of which we've just seen. So in the first approach, the fork command is used. And fork is a synonym roughly for clone or spawn. You'll also hear this jargon used. What the fork does is to make a copy, a clone in other words, of a process called the parent, and the child and the parent then execute exactly the same code. As we'll see in later examples, an if-else construct or the equivalent is then used to separate what the child should do from what the parent should do. So this is a straightforward division of labor approach. It's a separation of concerns. You have one process do something and the other process do something else. The pipe then acts as a vehicle for the two processes to talk. In more technical terms, the pipe is a mechanism for inter-process communication, typically abbreviated as IPC, and we'll see quite a bit of this. The second approach is quite different but more common. In this approach, a process generates a child process, but then the parent process goes away to be replaced by the child. On Unix-type systems, and even on a Windows system, there's a family of functions called exec, and there are variations on these for execute, which allows, in effect, one process to execute another process. And we'll see code examples of this. I'd like to suggest, basically as a confirming exercise, one further little experiment. So what you see down here is something else you can type in at the command line. You see sleep 5. So the sleep process is going to sleep, in this case, for 5 seconds. And then you see the pipe operator, again, the vertical bar. So I've put my cursor over it for emphasis. And then on the right-hand side, you see echo hello world. Now what's peculiar about this example, it's contrived, as you might expect, is sleep 5 does not generate any output, so nothing goes into the pipe, in effect, and echo does not expect any input. So what happens at the command line, what you're going to see is this. You're going to see hello world pop up on the screen, the right-hand side of the pipe. That process will be operating, and then roughly 5 seconds later, you're going to get the command prompt back. So let me run that here just for emphasis and bring back my command line prompt. So I'm going to clear the screen, and I'm going to do just what I did in the handout, sleep 5, and then I'm going to do the pipe, and echo. We'll just do hello to simplify this. So you can see the hello has returned immediately. That process has terminated in effect, and then you can see I got back the command line prompt because the sleep process had completed its sleeping.